I wrote my first game when I was 7 years old. I can't believe it, but it was over 33 years ago now. Man, I'm old. Anyways, I always say you're never too old to learn new things, and I certainly have been learning a lot since joining Convex. One of those things I've learned is a super cool trick to fake high frequency updates. When I first heard this, it absolutely blew my mind, as to me, this unlocked a whole bunch of things I felt that was going to be impossible and practical, such as real-time cursor movements that can be shared between multiple people. And I felt that was so cool when I first heard about it that I knew I was going to have to share it with you guys. So that's what this video is going to be about. I'm going to go through why I initially thought this was impossible, so basically the problem, and then we're going to explain what the clever solution was that one of my colleagues told me about. And then we're going to go through a live demo that I built to demonstrate this. And then maybe at the end, we'll do live coding session to come up with a new feature that we can add onto it. So grab yourself a lovely cup of tea and let's get started. Okay, so I think the best way to explain why I thought this wasn't possible is to take a look at this little diagram here. So we have our little app here that we want to be able to display real-time cursor positions from every other connected user. How would you do this? The way I've always traditionally thought you need to do this is that on the client side, you would record obviously the X and Y coordinates of the position of the mouse, and then you would send those updates every time it moves, or maybe once a second, to the server, and then the server would have to then somehow send it back down to the other clients. Now, the issue is that in serverless environments, this kind of all falls over for two main reasons. Firstly, in serverless environments, you don't usually have this persistent connection open at all times with other clients. So there is no way really for the server to send down to the clients. The other clients just have to basically request in the server what the current positions of the other cursors are, which is kind of like inefficient and results in like a lot of calls to the server. And secondly, and probably the most important one, is that when you're sending these updates to the server, we're going to be sending a lot of updates as the mouse moves like 60 times a second, times by the number of other connected clients. I mean, that's a lot of function calls. And generally on a serverless environment, you get billed by the number of function calls that you use. So for these reasons, I generally thought it was impractical / impossible to do this in a serverless environment. That was until one of my colleagues showed me this really cool little trick. So if we just see over here, I've got this thing that I prepared earlier, very Blue Peter fashion. So if instead of sending the updates every single tick, if we just batch them up into an array like this, where we have the positions over time, we can then send that batch up to the server on a much lower frequency, say once a second. And then that batch can be sent to the other clients. And then when it arrives on the other clients, the clients can just loop through that batch using looking through the array and the timestamp offset, and just replay those updates to make the illusion of a real-time cursor, except it is a real-time cursor, but it's delayed by a second. So that solves kind of like the high frequency number of updates that we're sending from the clients. But to solve the persistent connection one is something that Convex just does out of the box, because Convex has an open connection with all of the clients to do the data syncing. So to solve this, all we need to do is record the batch into a Convex database, and then the Convex will automatically then sync that down to all of the clients for us. We don't need to do any sort of explicit, WebSocket manager or anything like that. Convex just takes care of that all for us. And the result is you get a really kind of great real-time cursor experience, as long as you don't mind the 1 second delay. But you can't tell. These other clients don't know that there's a delay. So it works really, really well, as you'll see in a minute. Okay, enough theory. Let's have a look at this demo. So I've got two instances of the app running on the left-hand side, and it wants my name. So I'm going to call it Lefty on this side, and we can shuffle a nice panda. Looks good. On the right-hand side, let's call it Righty, just to make it really obvious. Little fox thing, sounds good. And now we can see when I move my cursors here, we see that Lefty's moving on the left, and then on the right, move it, Righty moves as well with a bit of a delay. And so down the bottom here, we can change some of the settings. So we've got the sampling interval. So if I just drop that down, for example, on this side, we can see that it's now a lot more smooth. because we're sending more packets. And if I bump it up like that, we can see that it's a lot more jittery. In fact, actually, let's just open up the developer console, and we'll be able to see. Let me just clear that. We can see now when I'm moving my mouse to the left-hand side, we can see that it says sending batch, and we can see we've got 11, 12. Let me just embiggen that a little bit. We can see that we're sending 12, 11 elements in that batch. But if I set the sampling interval to a much lower value and move my mouse, we can see we're sending 95 elements. If I set it right down to 5 milliseconds, we're sending 178. So that's what that does basically. It just limits the number of updates that we send in each batch. And the second setting here is this batch interval. So as you might expect, that is just going to change how often we're sending the batch. So I just change the sampling interval back to something. And then if I set this batch interval to a low value, we can see there's hardly any lag. There's 100 milliseconds lag between me moving the mouse on the left-hand side and you seeing it update on the right-hand side. And if we set that batch to be a lot higher, we should be able to see that there's a big delay now on the left-hand side. So I'm moving up and down, big delay. Moving left and right, big delay. Okay, so let's hop into the code now and have a look at how I built this. So we can just open up our Convex project, and let's start with our schema, because that seems like a sensible place to start. So in here we have our two Convex tables, users and cursor batches. For this demo, as you noticed, there is no auth tables, but I mean, if we were using Convex auth, they would go in here as well. But for now, it's just a simple user with a name, an emoji, and the batches is what we expect. We have batches related to a user, and then we have our array of movements in there, and we have our offset time since the start of the batch. And then for our functions, if you're not familiar with Convex functions are split between, you have your queries, mutations, and actions. And mutations is what you expect. It allows you to update data, and queries is used to retrieve data. So for our users, we have a mutation which allows us to create a new user, which just inserts into the database. And then we have a query which returns the users for us, and another one which just lets us get what all the active users in the application. Okay, and so also the cursor batch is equally quite simple. So if we go in here, we have a store mutation, which just takes the user ID that this set of batches is related to. Then we have our movements array with our positions and update. And then we first check to see whether there's an existing batch, because there's only ever one batch for each user. And then if there is, we just patch it. Otherwise, we insert a new batch into the table. And we have one other function down here, query, which basically just gets the batch for that given user ID. And because this is a Convex project, we get our dashboard for free. So we can hop in here and we can see the two tables we were just talking about, the users and the cursor batches. And we can see the positions and some of the update information within that batch. And we can just have a quick look at it working. Oh, come back here. So when I move my mouse here, we can see that it's updating that batch there, the lefty one. Move the one up here, it's updating the righty one. Yeah. And just to complete the loop, let's talk about the client side now. So if we hop over to the client here, we have our main entry point, which is a Vite React app. We have our Convex provider, which provides Convex everything. We have a me provider and a settings provider. I won't go into too much detail about these, but they're basically just contexts that provide the identity of you throughout the entire application. It uses local storage to set the ID when you create that new user, so that if we refresh the page, then we get the same user next time. So no auth, well, no complicated auth. The auth token effectively is your user ID in this case. And then the settings provider just, again, just uses local storage to save your settings and then provides that for the rest of the application. So the application itself, if we open up the app.txt SX here, we can see it's pretty simple. We have our me, that hook that we talked about before. If you don't have it, then we enter the user setup page, which is where we create the new user. I won't bother showing you that. But then in the actual application itself, we have the canvas and we have the settings. The settings is that little area in the bottom left-hand corner. And then the canvas is the main bulk of the code, and it's split into two different parts. You have the my cursor and the others cursors. So the my cursor is obviously going to listen for mouse movements here, and then it's takes the mouse event in. It's going to immediately update the position of your mouse cursor on the screen, so we get that nice optimistic kind of look. And then it's going to do some of that sampling stuff, and if it's been long enough between the last sample, then we just chuck it into this movement batch array here. And then on an interval, which is our batch interval, so every second or so, we record the time that the batch was started for the next batch, and then we do call our store cursor batch mutation, which is here. We do our use mutation, and it's a function that's going to take our user ID and our movements. And again, because this is a Convex project, we get this for free, all this type safety and stuff, and this generation. So makes things really nice and quick and easy to build. And then down here is just some UI for displaying your emoji and your name. And then backing back up to the canvas, our other part, the others cursor here. First we do is get basically all the users are in the application, and then we are going to exclude yourself because we don't need to show yourself because that's handled in the my cursor. And then each user is then passed to this remote cursors. And then here we are going to grab the user by user ID, and then we're going to grab that user's latest batch information. And then we're going to have this user effect here. So when this user's batch changes, we're going to stick it in this queue. The reason why we don't immediately execute that batch is because you might be working on the batch from the previous cycle. So let's have a look at Excalibur 10. So if you're currently replaying the previous batch and a new batch comes in, then you're going to get like a big jump of the cursor, which is not really nice. So instead what we want to do is we want to queue that next batch, so that once you finish replaying this batch, then it plays the next one, and so forth. So that's what the code is doing here. So we're enqueuing it here, and then we're doing the replay loop here. So we have this useAnimationFrame, which is just a utility hook that are pulled in that allows us to do use a request animation frame, but in like a React style. And the very first thing we do is like we look, is there a current batch that we're replaying? If there isn't, and there is nothing in the queue, then we can just jump out when we're done. Otherwise, we want to just shift it off the queue and then that's the next batch we're going to start working on, and record when we start it, so we can do the accurate time syncing of events when we're replaying it back. And now we're down here and we know that we're now working on a batch, so we can work out how long it has been since we started the batch. And then we loop over all of the updates, the movements inside that batch. And if this movement is not ready yet, then we just jump out. Otherwise, we pop it off our list of movements and we update the position on the screen. Yeah, and down here we just have a bit of UI code that we probably could share between the other one, but oh well. Just renders your emoji and your name. And that's about it for this demo. Oh, there is one other thing that I wanted to show, to talk about maybe, is in here, when we send the batch to the server, we aren't doing something called single flightedness. So imagine we set that batch interval time to be really, really short. So we send a batch up to the server, and before it's actually hit the server, we could have had another batch that we want to send off. So we may end up with multiple batches in flight towards the server at any one time, which could cause some sort of conflicts on the server, or we could get like out of order things happening. So a way that we can solve that is by using a helper from the Convex helpers library here, throttling via single flighting. So there's a really cool little helper here that means that would take care of this for us, ensuring that there's only ever going to be one batch in flight at any one time. So I just thought I would mention that here. Okay, enough demo. I think now what I want to do is try something a little bit risky. I want to do a bit of live coding and see if we can add a feature or two here, just as we're going along. So let's hop back into the code base. The first thing that I want to do is, I know that there's an issue here in this store function. We aren't limiting the size of these movements array that we're uploading. We're just chucking it in the database, and then that's just going to get synced with the clients. I think probably we should have a little bit of protection here just to ensure that this array is never too big. So I think what we can do here is we can just do a slice on it and just return, say, like the first 200 elements, for example. And then we want to do the same down here in this insert. But just to demonstrate what would happen if this was too small, let's just set this to like a really low value, like 10 here, and then hop back into our demo. And we move our mouse here, we see like the first 10 movements updates, and then it stops because we're obviously slicing, we're only taking the first 10 and then it's deleting the rest of them. So that's what we would get if the batch size was too small. So I think let's just increase it to something that's more reasonable. That's as big as we're ever going to want the batch to be. Let's say 200. And we'll see Convex is preparing the functions, and it's done. So now we hop back in, and yeah, everything's well and good again. Okay, so that was a simple little warm up. What I want to do now is considerably more complicated. What I want to do is make it so that when I am over here and I click my mouse, I want it to show up on the right hand side, or vice versa. I click on the right hand side, I want it to show up on the left hand side. So what that means now is that we need to change it from just sending mouse positions. We now also want to be able to send mouse clicks to the other side. So let's hop back into our code and see how we can do this. I think first place to start would be is if we look at our schema here, we can see that our cursor batches obviously only accepts an array of objects that are our movements, but we need to change this to be an array of unions of objects, and there could be either of kind mouse movement or click, for example, and that will allow us to then store those two different types in the database. And once we've done that, I think our batch will be just fine. We might need to rename this to something else, like maybe actions might be a better word, but that everything else will be fine and be simple there. And then our front end, we will want to change this so that we're not just not just listening for mouse movements, we're also listening for mouse clicks, and we're adding the kind into our array. But then I think everything else should be fine. It should get uploaded. And then when we're doing our replay, we'll obviously need to replay it and check what the kind of action it is. And if it's a click, we want to do some kind of animation to show, that a click has occurred. And to do this, I think I'm going to actually, seeing as it's 2025, rely on AI to do this. So just give me a hot second. I'm going to type in a prompt and see where we get to here. Okay, so we have a prompt now. It says, up until now, this app has been limited to only sharing cursor movements, but now I want to also have it share cursor clicks. To do this, we're going to need to modify the cursor batches table so that instead of an array of movements, we have an array of actions, where an action can be a union of different objects which have the kind, literal string, which can be movement or click. We will then need to update my cursor to record these click movements and push them into the batch. I don't want to apply the sampling interval throttle to mouse clicks. They should always enter the batch. Then when we replay in remote cursor, I want to show an animation of some sort when we're playing a click. Maybe have the icon and name shrink and grow and bounce the animation a bit so it looks nice. Let's give it a crack. Oh, it's pulled in the Convex rules, which I have defined up here. You can get them from the Convex documentation, by the way, but it really, really helps the cursor agent understand Convex a lot more. Great, so it's finished. I am tempted to click accept all, but no, we shall have a look and see what it's done. Okay, so let's scroll up. So the first thing it did was update the schema as requested. So it's changed this movements to be an actions array, which is exactly what we wanted. So that's good. And we've got a kind literal movement, kind click. Perfect. So then on the client side, we have changed it from cursor position to cursor action and action batch. Yep. Updated a comment. Very helpful. And now it's changed it so it's added the kind movement when it detects the mouse movement event. And then we have a click and we have no sampling in there. Perfect. This is, I think, exactly how I would have done it. So nice work, AI there. Okay, moving on. Remote cursor. So what has it done here? Is animating ref. Okay. This is making me a little bit nervous. Okay. Updated some more comments. And when it's doing the replay here, it's checking to see whether it's not animating. So it's going to, oh, I see. This is good. This is not exactly what I wanted, because this means it's going to start playing and then it's going to not replay any more motion while it's animating. Yes, I think that's exactly what it's doing here. So it's popping it off. If it's a click, it's going to start an animation, and then it's going to do a timeout, and then another. So it's doing nested timeouts. So it's doing a timeout to stop it. Oh, I don't love that. Okay, well, let's just have a look and see whether it's worked or not. Okay. I think the first thing we need to do, though, is, yeah. So Convex is yelling at us. So this is because we changed the schema from movements to actions. And the problem is that we have data already in the database. So if we're changing the schema and we already have data in the database, Convex is going to disallow you to upload this new change because it will conflict with the data in the database because it protects integrity. So normally what you would do if this is a production app, you would write a migration, which would you would make this movements or this actions value optional to begin with. And then we would migrate our data from movements to actions. And then we would do a second push where we would make it non-optional and we would remove the movements. But because this is just a demo and we're just doing this locally, not in production, we can just hop over to our table here and we can just delete this data here. Goodbye. And then we'll see immediately that Convex has recognized that it's now in a valid state and it's uploaded it for us. So then if we go back to our demo, let me just clear this and let's just shrink this a little bit. We can see that things are, oh, I think things were working. Maybe I need to refresh. Oh, yeah. Here we go. Here we go. It's moving. And if we do a click, hey, there we go. See that little animation there? But yeah, look, as I suspected, if I move and then I click, it pauses. It pauses the movements while the click is playing, which is not what I wanted. So it's close. I'm gonna accept these changes, but I'm gonna follow up and follow up prompt and see if I can fix what it's done here. So 1 second. Okay, and we're back. So I asked it to fix those issues and it's gone ahead and made some changes to our remote cursor file. So it's gotten rid of that is animating ref and has replaced it with a use state, which is looking more promising. It's gotten rid of from the while loop and it's going to set it to true and it's going to set a timeout to undo it. There's a potential issue there with the timeout, but we'll let it slide for now. And then it's updating a class name and it's created a CSS file with the animations. It's got rid of our tailwind styling and it's using the CSS styling, but that's okay, not to worry. But let's have a look and see whether it's actually worked. So move it around and we click. Hey! Oh, and by the way, I also told it to do like a little flash, which I thought would make it more obvious. So there we go. You can see I'm clicking on the right hand side and we see on the left hand side a little fox flashing and it's still flashing while movements are happening. So perfect. So So I think I'm just going to leave it there. I think we've done a good job with our changes here. I hope you enjoyed watching this and found this simple batching trick as interesting as I did and retrospectively as obvious as I did. I want to say a massive thanks to Ian, my fellow Convexarian. Is that a word? I don't think so. For pointing out this technique and for doing the initial experiments with this. I'm going to provide a link to the code and the demo that you can play with in the description down below. So please do leave me any questions in the comments, as I'm always happy to help. Oh, and if you'd like to learn more about Convex, I recommend checking out this video where I go into tons more detail about why I think Convex queries are the end game for derived state. Until next time, cheerio.